Hi everyone, and what we're doing today is we are bringing it all together. So this is all the stuff that we've done in chapter 7 regarding bivariate data, and the idea is that this task here will allow us to bring it all together and apply all of our things with a single set of data. So what we have here is the table of details of the win-loss records of the Australian Test cricket captains based on all tests from 1930 up until 2014. All right, so this infamously leaves out Sandpaper Gate. So what we have are the years that a particular person captained, their played, and their won records. So construct a stem and leaf and box plot for the number of tests played by the captains. All right, so stem and leaf plot, that goes back to univariate data. So what we are simply doing is we are looking at the frequency for the number of playeds. So if I open up my whiteboard here, make my whiteboard magically appear. Oh, you can't see me now. All right. So, what we are looking for is we need to draw a stem and leaf plot. So, stem, leaf, down the side. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll look at our data here. So I see, so Mr. Woodfull did 25, so Mr. Richardson did 5 as well. Mr. Bradman did 24. Brown did 1. Hassett did 4. Morris did 2. Johnson did 17. Lindwall did 1 as well. Clearly had a great time there. Craig did 5. Benno did 28. Harvey did just 1. Simpson did 39. Booth did 2. Mr. Laurie did 5. And we'll keep going through 1. 0 for 30. 48. 7. 28. 93 down the bottom there. 50 for Mark Taylor. 57 for Steve Waugh. 77 for Ponting. And Clark at the time of the data was only 37. So obviously from here, from what we have here is we have an unsorted data set. So we now need to go through and actually formalize and sort this out. So I'm going to quickly move this over here. Yes, it's blocking my data, but deal with it. So trying to do it as neatly as possible, although that doesn't always work. All right, obviously 93, that's fine. 77, that's fine. 50 and 57 are fine as well. 48. Now, obviously, I need to do 0, 7, 9. 4, 4, 5, 5, 8, 8. 17. And we've got 1, 1, 1, 1, 2, 2, 5, 5, and 7. So there's my stem, and there are my leaves. All right, so I now have a data set that I can work with. And we can now see my data again. So on the basis of this stem plot, where do you think the average or the mean is going to be? In what category do you think it's going to sit in? You think so? What's the average going to be? About 2 to 3? Yeah. It's probably going to sit somewhere around about here. I reckon it's going to sit somewhere about here. Because if you look at these numbers, so it's going to be somewhere in this bracket here. Now, the median, on the other hand, we don't need to do any calculations for. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Is that right? Should I have 24? 24. I have 24 pieces of data, which means to find the median, I need to find the 12 and a half. All right, remember that the median is equal to n plus 1 over 2. I need to find that number along in order, which is why I sorted this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 and a half. So it's 24 and a half. So on here, we can just say the median. What's the mode, by the way? What is the most single common number on here? 1. So most people usually only captured one test. And if you go back to look at the pre-1930 data, it's much, much worse. Like every captain was like one game, one game, one game, one game, one game, which is probably why they left it out. All right. Now, the only thing we need is the mean. And can someone use their CAS to work that out for me? All right. So remember, to do this on your CAS, you need to go into statistics and you need to enter the list as it is written. All right. And while I'm here, I will actually put my list 2 data in because I'll need it in a moment. It should not be 4.4. If you're getting 4.4, then I think something's gone horribly wrong. All right, so what I'm going to do is I'm going to replace my data table over here with my CAS calculator screen. All right, so now that I've got my CAS calculator screen up here, we need to go to calc, one variable, and it tells us here the average is 26.125. All right, 26.125. All right, remember this one here is our value that we want, x dash, that's our average. Our median is 24.5, as someone correctly said before. So now that we have our CAS, let's move this out of the way for now. So we've done our stem plot, which I just had up the screen before, and now I need to find the box plot. So what I'm going to do is I'm going to go to set graph setting, change it to med box. I want to see the outliers, and I'm going to hit set. I'm then now going to draw it, and hey presto, there's my graph. All right, that's my box plot there. So it starts at 1, goes all the way up to 93, and it is decided that the outlier of Alan Border, who did 93 tests, is an outlier. Yes, this is part of chapter 2, but the questions are combining it all together. All right? So, this data that I have here, I've taken the entire table and put it into my CAS. So what I can do now is I can move on and look at the other things here. So, in terms of the shape, the center, the spread, and the outliers, how would you describe the data? Let's look at the data as a histogram instead. All right, so let's change this to a histogram. We'll start at 0. We'll do steps of 10. How would you describe that data? There. What would you describe it as? Would you say it's centered, or would you say it's skewed? Yeah, it's very skewed. All right, and it is positively skewed. All right, because the center of that data set is much more towards the left-hand side than in the middle of the data set, which is what is important. All right, it is positively skewed with an outlier. The median number is 24.5. That means that half of the captains played less than 24 tests. %50 of the data, or 50% of the captains, captained between 4 and 38 tests. All right, remember you're looking at Q1 and Q3. Q1 is very, very low, and Q3 is only 38. All right. Question C says, from the data, who is the longest serving captain? All right. Who is the longest serving captain? So who is the person who captained the most? So if we go back and look at our data set again, move it out of the way. Who captained who is the longest serving captain? If you're looking purely at matches played. Yeah. Yeah. Now, if you were to look at it in terms of time, you might say, well, Simpson captained from 63 to 78. The problem is that if you look at all the other captains that took place between 63 and 78, you'll see that while there were a lot of tests that took place, he wasn't captain for most of them. World Series of Cricket was a very interesting time. They got Bobby Simpson out of retirement. He was like 45 to play Test cricket for Australia because everybody else was suspended for participating in one-day cricket. Oh, how times have changed. All right, so now that we've got this data in here, let's do some bivariate data analysis with it. Construct a scatter plot of matches won versus the matches played. Played is the EV. So EV means that it's going to be my x-axis. All right, so I'm now going to go onto my CAS. I'm going to go calc. Sorry, not calc. I'm going to do scatter plot. And I'm going to, along the X list, I'm going to put my played, and my X2 is going to be my 1. And I draw my graph, and it looks something like this. All right, so I have my scatter plot here. I've got a whole cluster down here, and it is going from down here up to here. Now, would you describe that? Would you describe that as a positive association, a negative association, a strong association, a medium, or a weak association? How would you describe the shape? So I've got a strong positive here, strong. Actually, I have a new toy to do this. There you go. I have just sent a poll. Let me know what you think. All right, I'm getting a few strongs, some mediums. Got some people who aren't paying attention. Wakey, wakey. All right, so I think it's fairly clear that we're all agreeing it's not weak. It is definitely not weak. Now, remember, what sort of number are we looking for a correlation coefficient for it to be strong? All right, if you think back to our diagram, actually I still have it here. We have this diagram here. Where would you describe that to be? What sort of number are we looking at? Have a guess. I mean, obviously it's positive, that's why I'm saying it that way. All right, so remember, if it is medium, we're looking between 0.5 and 0.74. Strong is above that at 0.75 to 0.99. Remember, a R value of 1 means that it is exact. It perfectly lines up. All right, so I'm going to close that poll. Share it with you guys. So what we're going to do now is we're going to actually find out what that number is. So on our CAS, calculate regression, linear regression, and that is the R value that I get. So, whoever said that they thought it was a strong connection is correct. Congratulations. All right, so thank you to those of you who said it was strong. You are correct. The R value is 0.9156. All right, so using this, we've also now got our A value and our B value to do a linear regression. So that what we can do now is we write down the slope of the least squares regression line. Now, the slope is at A or B. Is the slope A or B in my equation up there? The data that my CAS has given me is giving me an y equals ax plus b. All right, so when it looks like this, the A value is going to be my slope. Remember, the slope is whatever is attached to the x value. All right. All right. On your CAS, it'll come out looking like the way it does there. A is going to, so if it's y equals ax plus b, then A is your slope and B is your intercept. That means that based on this equation here, most test captains are likely to win about 48% of their matches. All right. And the R value of 0.91, we sort of predicted that it was going to be a strong positive, and it is. So that's what we've got there. All right, and that's all you need to do for those questions. I've basically done it for you.